So this is our last lecture in Unit 1 before we take our first exam. And in this last folder, what we're going to look at is joints, or what are also known as articulations. These are just areas in the body where you have two bones that are articulating or two bones that are actually coming together. So with this particular lecture, what I want to do is talk a little bit about how joints or articulations are classified. And then we'll spend some time looking at examples of joints in the body so that you can learn a little bit more about their structure. So when we talk about classifying joints, there's a couple of different systems for doing this. The first way that we can classify them is based on their structure, or actually based on how they're put together. And this is what's known as the anatomical classification. When we classify articulations based on the way that they're put together, they fall into three different categories. So if you look at this first picture here, this is actually a representation of a tooth. And here are the gums, and that tooth is sitting in a cavity in the jawbone. And where the tooth and the gums and the bone come together, we have what's known as a fibrous joint. So in a fibrous joint, what we've actually got are really strong, tight fibers that are running between the bones and holding them together. So in this particular diagram, if you can see just that small little area of white that kind of outlines the tooth, that's our artist's representation of those fibers that are attached to the tooth and attached to the jaw and are holding that tooth in there very securely in a fibrous joint. Usually, because the fibers that are holding two bones together in a fibrous joint are really short, fibrous joints tend to be joints that are immovable. However, there are a few examples of fibrous joints, and I can think of one in the lower leg where you've got fibers that are a little bit longer that run between the bones and hold them together. And because of that, you've got a joint that's able to have a little bit of movement. A second type of joint, when we classify them just based on their structure, is what's known as a cartilaginous joint. So if you look at this picture here, what we're actually seeing is the hip. So we've got a left hip and a right hip coming together. And right here is the space between where those bones come together. And we have a pad of fibrocartilage that sits right there and actually holds those two bones together. Because we've got fibrocartilage, we've got cartilage that's sitting in there holding the bones together, this is a good example of a cartilaginous joint. So cartilaginous joints have cartilage that's actually connecting the bone. This is an area which is known as the pubic symphysis, where those two hip bones come together. So the pubic symphysis is a good example of a cartilaginous joint. If you look down here, so we're seeing the knee in this particular case, and in the knee, we don't have fibers that are running between the bones and attaching them together, so you don't see any little white strands of fibers. We don't have a pad of fibrocartilage that's attaching these bones of the knee together. What we have instead in the knee and in actually most of the joints of the body is a synovial cavity. So a synovial cavity is a little cavity that's filled with kind of a thick, greasy fluid, which is known as synovial fluid. And because we don't have a pad of cartilage sitting between the bones, we don't have fibers that are really tightly binding them together. Instead, we find this synovial fluid in between the bones. These tend to be joints that are much more movable than a fibrous joint or a cartilaginous joint. They tend to have a much wider range of motion than those other two joint types because of this synovial cavity and the way that they're put together. So the other way that we can classify joints is based on their physiology. And when I say based on their physiology, basically what I mean is how much movement they are capable of. So some joints in the body, believe it or not, don't move. Most of the things that you're probably familiar with that you think of as being a joint are joints that freely move and fall into the category of diarthroses, which we'll talk about in a minute. But I want to come back up here and talk about synarthrotic joints, or what are known as synarthroses. These are joints that are immovable. So if you look at this picture over here, we've actually got the sutures between the skull bones, so the area where the skull bones are fused together. And you'll notice that in those areas, we have this little area that's represented in white. So that's the actual suture where those bones are being held together. those bones are connected in a way that makes them unable to move. And because of that, this is a great example of a synarthrosis. What we actually see attaching these bones in the skull are fibers. So this is our synarthrotic joint when we classify it physiologically. It is a fibrous joint when we classify it based on its anatomical structure. And this is an example of a fibrous joint that is immovable in this particular case. So if you look over here, here's our next type of joint when we classify them based on function. So this is an amphiarthrosis. And amphiarthrosis is a slightly movable joint. Most cartilaginous joints are slightly movable. So most cartilaginous joints fall into the category of also being amphiarthroses. What we're actually seeing here is a section of the vertebral column. So we've got some vertebrae, and you'll notice that each one of those vertebrae has a little white pad of cartilage that's sitting in between them. So this is an example of a cartilaginous joint. Each one of these joints where we've got this pad of cartilage allows just a little bit of movement. It doesn't allow a lot, but between this bone and this bone, there's a little bit of movement, and between this bone and this bone, we've got an amphiarthrotic joint, so we are allowed to have a little bit of movement. If you're thinking about your vertebral column and thinking, well, I can bend that forward, I can bend it back, I can bend it from side to side, it seems pretty movable. That's because there's a whole bunch of these individual amphiarthrotic joints that can move just slightly. And when you combine the slight movement of the amphiarthrotic joints and you multiply that by all of the vertebrae that make up the vertebral column, now suddenly you've got a much larger range of motion than you would have with a single amphiarthrotic joint. So the last type of joint when we classify based on physiology is a diarthrosis. I mentioned these before. These are the joints that are freely movable. Most of the joints in our bodies are diarthroses. This is where we're going to focus most of our time and attention for this particular folder because, again, they make up most of the joints of the body, but because they are the joints that move, they're also the joints that most commonly are injured and that you most commonly are treating in a medical setting. You don't really see people coming in with a sprained suture in their skull, right? Because these joints don't move, they're not as likely to be injured as diarthrotic joints. So I want to talk a little bit more about the structure of these diarthrotic or synovial joints with the next slide and talk about what it is really that makes them so freely movable. If you look at this picture here, what we've got is an artist's representation of a simplified synovial joint, and then we also have an actual synovial joint. We're looking at the shoulder that has been cut through longitudinally from a cadaver. So we can talk about some of these structures that are being represented on our cartoonish drawing of a synovial joint and then apply that to what we're seeing in the actual shoulder. So here's a really basic synovial joint. We've got bones represented here in yellow. This is the joint in here. You'll notice that, again, it's a big cavity, and that cavity is going to be filled with synovial fluid. So a little bit about synovial fluid. It is thick, it's greasy, it helps to resist compressive forces where those bones are coming together. So the root word synovi, which synovial is actually coming from, is a word that means egg white. So what you're thinking of when we're talking about synovial fluid is a thick, greasy fluid that has basically the consistency of egg white. Synovial fluid is really important to the health of the joint. So it actually acts as a fluid similar to the blood because joints don't have a great blood supply. And so the nutrients, the oxygen get into the synovial fluid. And then as the synovial fluid is kind of circulating through that joint, it helps to distribute the oxygen and the nutrients to the tissues within the joint. So we've got synovial fluid. I want you to notice on the tips of each of these bones, there's an area of blue that I just ran my pointer across. And this area is composed of what's known as articular cartilage. So articular cartilage is there because it's cushioning on the ends of the bone and also because it really helps to reduce friction in the joints. So when I was an undergrad, I had a professor who was an articular cartilage expert, And one of the things that they determined in her lab was that if you were to take two pieces of articular cartilage in a joint and rub them against each other, assuming the joint's healthy, you would have a friction coefficient which is 1/6 the friction coefficient of ice on ice. So translating that into real world terms, imagine taking two ice cubes and rubbing them together and how slick and friction free that would be. The articular cartilage in the joint has 1/6 the friction of ice cubes rubbing against each other. So this articular cartilage is really important to the health of the joint. When articular cartilage starts to break down, that's what actually causes osteoarthritis. So we've got this articular cartilage, we've got this open space, this joint cavity that's filled with the synovial fluid, and you can see both of those things over here on the shoulder. So in white, you see some articular cartilage here lining the head of the humerus. You can also see some articular cartilage here lining the clavicle where those bones come together. And you can see the joint cavity, which would be normally filled with synovial fluid, right through here. So we've got a little bit of space that each of these bones that are coming together to make up the shoulder joint can move into. And that allows this joint to be much more flexible, and all diarthrotic joints to be much more flexible. There's a couple of other things associated with synovial joints that I want to mention. So synovial joints have what's known as the articular capsule. It's represented in green in this diagram. This is a capsule that's just kind of forming the wall of the joint cavity. It's also attaching these two bones to each other. And then the last thing that I want to mention is that all synovial joints have what are known as reinforcing ligaments. And there are 3 different types of reinforcing ligaments. So if you look at this picture here, you'll notice we have these bands of fibers. These are collagen fibers, so stronger than steel, of the same size, that are outside of the joint cavity, and they are connecting these two bones together, and they're helping to stabilize the joint. These are reinforcing ligaments. Specifically, the ones that you see here are extracapsular reinforcing ligaments, and the reason that they are called that is because they are found outside of the joint cavity. We also, in a few joints, and the knee is a good example of this, have what are known as intracapsular ligaments. So intracapsular ligaments are ligaments that are actually inside the joint capsule and that are actually physically attaching the bones together inside of the joint cavity. The ACL and the PCL, if you're familiar with those particular ligaments of the knee, a lot of times they're ligaments that many people in the class have torn. Those are examples of intracapsular ligaments. The last type of ligament is what's known as a capsular ligament, and when capsular ligaments are present, really these are just kind of thickenings of the articular capsule. So they would really just be a part of the capsule, and the capsule would really just be kind of thickened in the case of a capsular reinforcing ligament.